Hello. Welcome back. Wow. Why do I always need to cough right when I turn on the computer? Welcome back to 3D index numbers, the CPI and beyond. All right, what's an index number? An index number provides a simple way to compare measurements made at different times or in different places. The value at one particular time or place must be chosen as the reference value. Sorry, I had to pause and just get all that cough out. Whoo, that was rough. Okay, so an index number. This is how we compare like the price of groceries in 1970 versus the price of groceries in 2023 when I'm recording this. The index number will be the value divided by the reference value and then times 100. Really, we do the times 100 because nobody likes, not nobody, most people, the general public, do not enjoy decimals numbers. So we times 100 so that we can have a number that makes sense to us. No particular rounding rule for index numbers, but we're going to round them to the nearest tenth. So just one decimal place in this book and in this class. But make sure you check the homework, read the instructions. Okay, so average gas prices per gallon. U.S. Department of Energy for 65, 75, 85, 95, 05, 15, and 2020. Now, this is the price per gallon. Yeah, I remember this. Man, I miss those days. This 226, I don't know where they are. Definitely not where I was paying for gas in 2020. So here we're using 1985 as our reference. So $1.20 for gas, per gallon of gas. That's our reference number. We call that 100, all right? 100 is average. So the gasoline had a price index of 25.8 in 1965. That means it was like 25% of the gas price in 1985, whereas in 2015, the price index was at 210 because the price of gas in 2015 was 210% of the price of gas in 1985. All right, so always to a reference. Suppose the cost of gasoline today is $2.70 per gallon. Use the 1985 price as the reference value and find the price index for gasoline today. And we just saw that 1985 price was $1.20 per gallon. We'll take 2.70 divided by 1.20 multiplied by 100 and we'll get 225. The current price is 225% of the 1985 price. The gas index in 1985 dollars per gallon is 225. All right, that's how we would phrase it. Suppose it costs $16 to fill your gas tank in 1985. It really did. How much did it cost to buy the same amount of gas in 2015? Well, the table shows the price index for 2015 was 210, right? We just talked about that, 210. Pardon me, I am so sorry for that, if that was in your ear. Caught me by surprise. Which means that the price of gasoline in 2015 was 210% of the 1985 price. So the 2015 price of gas that cost $16 in 1985 was 210%, written as a decimal, multiplied by 16, or $33.60. So that same tank that you filled in 1985 for $16, it'll now cost you $33.60. Craziness. So you could change the reference value, right? Any reference value can be used to calculate an index number by changing the reference value that results in different, changing the reference value changes the index number, right? So you always have to know what your reference is. Looking at the price per gallon, again, right? Everything's still the same. In 1985, the price index, that's the one we looked at before. But if we think of 2005 as our reference prices, well, then 1985 was only about half the cost, right? A price index of 51.9. Which makes sense because 2005 compared to 1985, when the price index is 1985, 2005 is almost double, right? A little more than half. So it depends on which way we're looking, how we want to compare these, which place we'll find are 100.0, okay? So using the 2005 price as the reference value, all right, 2005 price is 231. As the reference value, find the price index if today's gasoline price is 270 per gallon. Compare your answer to the same gasoline price example 1 where 85 was the reference year. All right. So with 2005 as the reference value, the index number for the assumed 270 price today is 270 divided by 231 times 100, which is 116.9. As we should expect, this price index is different from the value of 225.0 found in example 1. Both numbers are valid, but it only means something if you know the reference value. And that's how people get away with talking about, you know, some of the same people say, oh, inflation's higher now, oh, salaries have increased. What are they comparing it to? All right, always have the same reference year. So specifically, the 2005 price index tells us that today's price of 270 is 116.9% of the 2005 price, while the 1985 price index tells us that the price of 270 a gallon is 225% of the 1985 price. It doesn't look so bad if we're looking at 116. It looks awful if we're looking at 225% from the 1985 price. The Consumer Price Index, or CPI, is based on an average of prices for a sample of more than 60,000 goods, services, and housing costs. It's computed and reported monthly. The rate of inflation from one year to the next is usually defined as the relative change in the Consumer Price Index. We've been doing a lot of relative changes. We know how to do that. Now, you could look at the table on page 192 of your textbook for the average annual consumer price index from 1982 to 1984. That's 100. All right, but check out the table, look at it. Suppose you needed $40,000 to maintain a particular standard of living in 2014. How much would you have needed in 2020 to maintain the same living standard? Assume that the average price of your typical purchases has risen at the same rate as the Consumer Price Index. So we compare prices for 2 different years by comparing the CPIs for those years. CPI at 2020 was 258.8, and the CPI at 2014 was 236.7. This ratio gives us a 1.093. That is, typical prices in 2020 were 1.093 times those in 2014. If you needed $40,000 for your standard of living in 2014, then in 2020, you would have needed 1.093 times that $40, or $43,720 for the same standard of living. Not bad. In 6 years, you only need $3,000 more dollars, almost $4,000. Inflation, it happens. Find the inflation rate from 2015 to 2016. How does it compare to the inflation rate in the late 1970s? Well, the inflation rate from 2015 to 2016 was, these numbers are not right. This is looking at 19 to 20. And I apologize for not catching that before I came here. We'll keep these numbers. We just changed the problem. All right. I apologize. I didn't catch those first. But they should absolutely be related to the years that you're talking about. The rate of 1.2% is much lower than the rate of inflation in the late 80s or the late 70s, which they asked us about. I don't know. That was my bad. Given a price in dollars for a year X, so we'll call it dollars per X, the equivalent price in dollars for year Y, dollars for Y, is the price in X multiplied by the CPI for Y over the CPI for X. Notice the subscript of X is in the denominator because we're multiplying by the price in X. Our answer will be in terms of Y. So our numerator, our answer will be in terms of Y, where X and Y represent years. Okay, So in 1987, the mean or average salary for Major League Baseball players was $412,000. In 2020, it was $4,430,000. Compare the two salaries in 2020 dollars. How does the rise in baseball salaries compare to the overall rise in prices with inflation? Okay, so we convert the 1987 salary of $412 into 2020 dollars. So salary in 2020 is the salary in 1987 multiplied by the CPI of 2020 divided by the CPI of 1987. And we can find those values from the table in your book. Remember, table in your book. When we multiply and then divide, we'll get about 939,000. Keep in mind these have four significant figures. This only has three. So we report our answer to three significant figures. According to the rise in the cost of living, a salary in $412,000 in 1987 is equivalent to a salary of $939,000 in 2020. Note that the actual 2020 average salary of over $4 million was about 4 times what it had been if the average salary had risen only with inflation. We conclude that in real terms, that is, terms adjusted for inflation, average baseball salaries rose by approximately a factor of 5 from 1987 to 2020. It's about 5 times higher, right? About 5 times. So a factor of 5 is how they changed. All right, that was the quick and the dirty. Let me know if you have questions. Good luck on your homework. Thanks for listening.